Hey there, C-Sharpers. My name's Matthew. I'm the C-Sharp Artisan, and this is the third video in my series on Nullable Reference Types. In the last video, we introduced the key concept of annotations, where you can put a question mark after a reference type declaration, and the question mark indicates that that particular variable could be null, whereas if you leave the question mark out, it indicates that that variable likely won't be null. So it sure looks like this creates a new set of data types. For example, if you've got Polygon without the question mark and Polygon with the question mark, it kind of feels like you've got the non-nullable polygon as a type and the nullable polygon as a type. In much the same way with a nullable value type, you could have a Boolean and a nullable Boolean, and they're different types. So the reality is that is not what is happening. When you add an annotation to a reference type, it doesn't actually change the underlying type. This is confusing and maybe a little counterintuitive. So in this video, we're going to use some reflection code to really look at this and see what's actually going on and do a comparison between nullable reference types and nullable value types and see how they really are quite different. So let's start here looking at my little field inspector class. This class has a single method called inspect fields, where you pass it an instance of some type. And what it does is it uses reflection to get a list of the fields on that type. It loops the fields and prints out the field's name and the data type, the name of the data type of the field. So let's create ourselves a little class we can use to test this. Let's call this public class some class. And let's start off by giving it a property, an int, called normal int. And we can initialize that to 0. And now let's also give it a nullable int. And we can initialize that one to null. Now let's give it a string, which we can initialize to the empty string. And we'll give it a nullable string, which we initialize to null. And now just for completeness, why don't we give it a polygon? And a nullable polygon. So we've got 6 fields here, and they come in pairs, a regular one and a nullable one for 3 different types. So now we'll go back to our program, and we can say field inspector dot inspect fields some class, and then we'll just give it an instance of some class, and it should now print out that info. Let's run it and let's see what it does. We'll press enter to begin. Very good. So field normal int is a int 32. Wonderful. Field nullable int is a nullable tick1, which is the name of the generic nullable t struct. So what you can see is that our nullable int and our regular int are 2 totally different data types, as we would expect. Now moving on to our string, the normal string is a string, and our nullable string is also a string. That's curious. And our normal polygon is a polygon, and our nullable polygon is also a polygon. So when I first realized this, I found this kind of shocking. You would think int is to nullable int as string is to nullable string, or int is to normal int as normal polygon is to nullable polygon. But that is not the case. These things are fundamentally different. When you put the question mark attribute on a field or a parameter or a local variable, when you give it that annotation, it does not change the data type. The underlying data type stays exactly the same. A string is a string is a string. So if it doesn't change the data type, what on earth is it doing? And the answer is, it's adding a custom attribute. So I have some code over here that I had commented out that I'm going to bring back. This goes in our field inspector. So after we print out the field name and type, we go fishing for a custom attribute whose name is system.runtime.compilerservices.nullable attribute. And then once we've got that attribute, we go fishing for some flags, for a little byte array of flags. And then if we find that, we can write out the nullable attribute flags for that field. So having added this in, let's run it and see what we get. So the normal int doesn't have that attribute. The nullable int does not have that attribute. The normal string does not have that attribute, but the nullable string, which is a string, has the nullable attribute with the flag set to 2. Our normal polygon doesn't have it, but our nullable polygon does have it, again, with the nullable attribute flags set to 2. So annotation doesn't change the data type. Annotation just adds a custom attribute. So attributes are fun. You've probably used them. For example, if you've done any ASP.NET controllers, you've used the controller attribute to define a controller method and name it and say whether it's a get or a post. Or if you've done entity framework, you've probably used attributes to say what is a data table mapping and what's a field mapping. If you've done automated tests, you annotate your test fixtures and your tests. So attributes are meta programming. You add metadata to classes and fields and member variables and local variables, and you add these attributes that then some framework or tool reads at runtime through reflection and then takes some sort of action. And the fun thing about attributes is you can define your own. And I've created a little attribute here called the might be null attribute, which targets fields and parameters. So instead of saying string like that or polygon like that, one way you can think of this is that there is an attribute on that field that tells you it might be null. Or here on the polygon, that it might be null. Or going back to our polygon class, that our input parameter, polygon, might be null. Whoops. So that is really what's going on here. That is a kind of better understanding of what the question mark does. Okay, maybe you're a little surprised. I sure was when I discovered this, but this is a critical distinction. And for you to really use this feature correctly, you need to understand what it's doing. So now you do. The question mark, once again, doesn't change the data type. It adds a custom attribute, kind of like this, that the C# compiler can use to understand whether it should check that item, that variable, or that parameter for a possible null reference exception. And if so, then it gives you a compiler warning. So next, let's actually turn the feature on, generate some warnings, and see how it works in practical terms. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.